yeah, we've updated the application version. We observed how the transition worked. That was pretty neat. Seeing rollouts in action now. Before we come to rollouts, we first should look at what actually happens behind the scenes. So we are going to create another deployment to observe, not this time the application perspective, but we are going to observe the deployment more closely. So first I'll create 10 replicas, just so that the process will take a few seconds. So we're good. Kubectl. Get deployments. Deployments. Oh, here we go. 10 application instances we have. We are describing the deployment, and there's also a list of events, as you can see here. So, for example, scaled up replica set, scaled down replica set, scaled down replica set, scaled up replica set. So the deployment is scaling up replica sets. That's interesting, isn't it? Can you imagine why? From what you know about replica sets. What are the two things? What is this? What is this one thing that works with the replica set in terms of changing it? And what is the one thing we've observed that doesn't work as expected?
I'd say what works with regards to changing it is the number of replicas.
Exactly. And what didn't work? As expected?
Changing the image without
exactly. Now,
strategy.
Now, if you're thinking about how would you implement a deployment controller by using the observed behavior of a replica set, how would you do it? And the answer is close. If you already understood what you understood, how would you build a deployment controller that does what the deployment does in a rolling upgrade? How would you do that using replica sets?
Maybe creating two distinct replica sets and scaling one up while scaling the other down.
Exactly. Very good. Exactly, that's what's happening. So let's try to observe that. So we can definitely see some traces of that. So we can see that replica sets are scaled up and scaled down, and you can also see that replica sets are changing in identity. So it seems like the replica set is basically means to the deployment, and that it is basically a layered structure. You have pods, you have replica sets, and replica sets do just enough to serve for the purpose of a deployment. I don't think it's a coincidence. I think it's by design. So we have now 10 replicas. Sometimes it's a pity that containers are so fast because it makes demonstrating the process harder, time critical, so to say. All right, let's change the application version back to blue.
There is this value in which on how many percent of the whole containers can be can be updated simultaneously.
Simultaneously.
So, where can this setting be adjusted?
Yes, let me Google that for you.
Because it's obviously not in the configuration.
Yeah, it's because I mean there are defaults, and the default
okay, so
is 25%. So the question is, what was the name of that? Kubectl describe. We have. We have a strategy type recreate. There. This doesn't happen. So let's go back to the deployment. We have to first switch it back to the other strategy. So rolling. We just delete the strategy. And we leave it to green for now. Yeah, it doesn't affect the existing one because it only affects the transition. So it didn't do anything to the deployment. It just noticed, or it just updated the internal specification of the deployment. So it is now aware that it should do rolling upgrades, rolling updates. But it also noticed that there's no change to the replica sets needed, and therefore didn't do anything. But it did update the specification of this particular deployment object. So in Kubernetes, you always have to understand that there's this one part of Kubernetes that does nothing but storing these YAML specifications. So this is when you'll get a successful apply, the specification has been updated. And then there's a controller attached to the resource that does the actual work. So it's one thing to update the specification, and it's another thing that the controller has to determine whether to take action. So in this case, Kubernetes API took the spec, updated it, and the controller said, nah, that's nothing to do for me. All right, so there we'll give them something to work. So we switched back to green. Is that the last version? Yeah, no, we have to switch back to blue, right? I can see that here. Now we are currently green. So your question was, where's the in-flight limit?
Yeah, exactly. Because, for example, when you have different configuration files, you can define this limit within the configuration file.
Yeah, you can. I just have to find out what the name is. Here, rollover, aka multiple updates and in-flight. So with 10, we would have a rollover of 25%, which would be 2, I guess. Well, I don't think it's rounding to the next integer, so 2 maybe. So each time a new deployment is observed by the deployment controller, a replica set is created to bring up the desired pods. If the deployment is updated, the existing replica set that controls pods, blah blah blah, are scaled down. Eventually, the replica set is scaled to 0. This is what we've anticipated, and this is how it works. So if you update a deployment while an existing rollout is in progress, yes, the deployment creates a new replica set as per update and starts scaling up and rolls over the replica set. Well, I think it's somewhere in the rolling update. Nope, we don't want to have the in. I think this one. No, it's not rolling back. You know, sometimes what I feel frustrating about the Kubernetes documentation, it is quite rather comprehensive, but it also goes into so much details with blah blah blah, and so much of the details when I don't want them. That's why I personally think a simple tutorial for beginners much better, as this sometimes has the information density like looking into the sun. It's just too much in a short period of time. It's good, but even the tutorials, they go much into details. But it's just my feeling about this. Okay, let's try to check out to create a deployment to roll out a replica set. Give me a second. I'll try some other information source where I possibly get the answer quicker.
Just check it now that much. I can also do it after the.
No, it's all right.
It's now okay.
I mean, obviously it takes a bit if I have to look it up myself, because I know it's in the settings, but I don't know at the top of my mind what the setting is called. I think it's called max search, rolling upgrade, max search, and max unavailable. I'm not familiar with the exact semantics of the two, but we can look it up in the Kubernetes. Once we know how the thing is called, we can look it up. So, the rolling update deployment. The deployment updates pods in a rolling update fashion. You can specify max unavailable and max search. Max unavailable is an optional field that specifies the maximum number of pods that can be unavailable during the update process. The value can be an absolute number or a percentage. Interesting. The absolute number is calculated blah blah. Once new pods are ready, old replica sets can be scaled down further, followed by scaling up the replica set.